Hello and welcome to another video, this time on MAT 2014 questions A to E. I'm doing this because I was surprised today when I saw a flurry of comments, like two or three, thanking me for the videos. So I felt inspired to do another video. There we go. But yeah, also because I want to catch up with the 2014, 2013 ones. I think I've still got the big ones to do in 2013, which is really annoying me because I want to move on now because I've done them, but I want to pop up a video so people can see. But it's just finding the time to do these things. Now this is just the A to E, so it shouldn't take very long. And these early ones, they're really straightforward. I tell you what though, one thing which occurred to me when I was just checking my answers, checking that I'd done, checking that I've got the right answers on the website. I actually realised that you can make some really weird mistakes. Like this one, I actually figured out the correct answer, saw it as that, and then I think my eyesight or something got to the better of me because I wrote down D, even though D is so obviously wrong in this question, it's ridiculous. But I meant E, but obviously, you can't really say that to the examiner from a distance after you finish the test. So do check your answers. That's what I was saying. Like you make the craziest, crazy mistakes sometimes. Okay, anyway, let's get on with it. You've probably found many of these early on questions. They often are, quite nice questions after you've got used to them. And so, maybe you're just watching though, looking to see if there was a quicker way of doing it or just a different way of looking at it you might have preferred. Probably not, to be honest, particularly on this one. This one is a standard, like, okay, you've got a quartic. The best way to do this is to sketch it every single time. Whenever you want to find, solve an inequality with something like this, sketching is a really powerful way of solving inequalities. So let's consider the graph y equals x to the 4 minus 8x squared minus 9. We can naturally factorize that because it's a disguised quadratic. We can factorize that into x squared minus 9, x squared plus 1. Let x squared equal u if you prefer to do it like that. This is what's known as an irreducible quadratic, which means you can't factorize it. That's going nowhere unless you allow for complex numbers, complex factors, but let's not go there. And so we are going to factorize this one with difference of two squares and see that this is some kind of quartic. And it's a right way up quartic as well, which means it starts from up here and ends up over there. How do I know that? I look at the dominant term. Yeah, the dominant term, when x is positive, x to the power 4 is very large and positive. So you know that when x is up here positive, y should be up there positive. And likewise, when x is negative, you're going to get a positive value from x to the power 4. I mean like minus a million. When you do to the power 4, you've got minus a very big number, positive a very big number, and so it ends up there. So we know it's going to come down here, go up there, and then I guess it hasn't got any more intersections with the x-axis. Now it might actually be the case that it looks like that, but who cares? It doesn't matter. Like, maybe it's something more like that, but it does not matter for the purpose of this question. We haven't got to worry about that. Clearly, oh, hang on, I have drawn it slightly incorrect. I apologize. Clearly, it's going to pass through minus 3, 3, and then do something else, which I'm not interested in. And so we want it to be underneath the x-axis. And so the answer is A, minus 3 to 3. You've probably fast forwarded this question because you found that one so easy. Fair play. This one, okay, straight away I'm looking at that thinking, well, I can't take logs of a negative number. I can only take logs of values bigger than 0. So I'm going to just quickly deal with this quadratic in here and complete the square on it. It just seems like the natural thing to do. So I got x minus 1 squared plus 1 after completing the square. And then I thought, well, that's nice because at least this bit is always greater than or equal to 1 for obvious reasons. And that made me think, well, you're logging a number 1 or bigger, which means the answer is always going to be 0 or bigger because log of 1 is 0 and log of a number bigger than 1 is positive. And so I know that basically that rules out that one and that one, even though I did write down D at the end. I must have just glanced at the wrong value. It's really weird looking back on my notes. Okay, and then I also know that when x equals 1, y is going to be equal to 0 here, because when you plug in x is 1 here, you get a value of 1, and log of 1 is 0. Knowing that, it has to be E. Has to be E. Everything else is not hitting at 1, 0. So that was that one. You've probably fast forwarded this question as well because it was so straightforward. This one's a little bit more awkward. You might start off thinking, well, differentiate once and find where that equals 0. But that actually doesn't yield any fruit, because when you differentiate this, and this is standard, standard kind of like a mistake you might make. You might think, oh, differentiate it once, set it equal to 0, plugging in x equals 1. You get 3k minus 2k, that's 1, so another minus 2, and then plus 2 minus k. Now watch this, that cancels, and they're trying to lure you into putting down all values of k here. But if you're somebody like me as well, that's the kind of thing you would do. If you don't read that bit, has a turning point, that must be a minimum. Well, if it's a minimum, then the second derivative is going to be greater than or equal to 0. And the second derivative here is equal to 6kx minus 2k plus 1. Yeah, I've just differentiated this again. Okay, and we want this to be greater than or equal to 0. And that occurs, well, remember x is 1. You get 6k minus 2k minus 2 is greater than or equal to 0. So 4k is greater than or equal to 2. So k is greater than or equal to half. Now, here, I mean, this is one of those cases where you think, like, quite obviously it's that, but you might be slightly worried about the non-strict inequality. It doesn't really worry me too much, because this is about like the formal definition of maximum and minimum. I suppose you could take the case where k equals a half and actually work it through. It's nothing to worry about, basically, is what it boils down to. If k equals a half and x equals 1, we don't end up with a minimum, I believe. I think we end up with a point of inflection there, because when k equals a half, you're going to get the second derivative equal to 0. We could quickly check either side of x equals 1 to demonstrate that that is a point of inflection, but my hunch is that is a point of inflection. So the answer is C. What I'm pointing out there with points of inflection is it's not sufficient that the second derivative is greater than or equal to 0. You've also got to show a sign change either side. I suppose, though, what are the other alternatives? It's only really even powers of x that you have to worry about points of inflection being mistaken for, maximums and minimums being mistaken for points of inflection. Anyway, let's do this one. We've done that one. That one wasn't too bad. This one, my advice to a student who asked me the other day on this was, I'll just pick a number for m and see which works out. Don't pick an obvious one like m is 1. Pick a slightly more awkward one like m is 3. That's what I did anyway. So I'm going to use y equals 3x here, and this is 1, 0, and I'm trying to reflect it. Well, we can do this kind of stuff straight away, because that's I'm talking about the gradient here. The gradient of that line is minus a third. If I can find where this intersects here, and then just apply a vector there, and then the same vector again here, that would be lovely for finding the reflection. There are clever formulae you can use for this as well, by the way, because some of you may be really flash on these kind of questions and use a clever formula. Credit to you there. I'm going to do this like the sort of slow long AS way. Okay, so that's got a gradient of minus a third. I hope you can kind of like just see straight away that that must have equation y equals minus a third x plus a third, because then that way when x is 1, y is 0. So I just kind of wrote that down. I now need to find where it hits this line. So equate the two, solve it, you're going to get, that's 9 thirds, so plus a third, 10x over 3 equals 1 third. So x is going to be 1/10. And that's the coordinate where it hits there, and that looks about right. And when x is 1/10, y is 3/10. Great, that gives us a way, if I can just point at that one and say it's 0.1, 0.3. Yeah, now how I get from here to here is how I get from here to here. Yeah, that's the way I see it. Now, as you can see, I need to go back 0.9 in the x, giving me minus 0.8, and I need to go up 0.3 again, giving me 0.6. Okay, I've reflected it. And then all I'm going to do is I'm just going to plug in m is 3 and see which one gives me the right answer. Yeah, and there is a danger that two of them give you the same right answer here, but I took the risk. What the hell? Anyway, when you do that, you get 1 minus 9, which is 8, minus 8, sorry, 1 plus 9, which is 10. So you've got minus 8 over 10, that's minus 0.8. Here you get 2 times 3 is 6, over 10, 0.6. This one works. Try all the others. They don't work. Trust me on that. And I fully invite you to plug them in. They do not work. And so the answer is D. Okay, one more to go. Quick one this video, it's the later questions in the short questions which take longer. This one also, I think it's fairly obvious what you want to do here. Sine squared and a cos, well, we're going to write that as 4 minus 4 cos squared x plus 4 cos x plus 1 all squared. Personally, I'd much rather let cos x equals c here. But I bear in mind that cos x is trapped between 1 and minus 1. I would bear that in mind. You're going to get minus 4c squared plus 4c plus 5 all squared. Yeah. Now, I don't like that. And I know that if you've got a minus b squared, you're well within your rights to change it to b minus a squared. Why is that? Because when you square a negative, it's the same answer. Yeah. You're always allowed to do that. It's a cheeky trick. So I'm going to do that. Yeah. Just to help me complete the square, because I just don't like the minus 4, basically. It's just to help me complete the square. 4c squared minus 4c minus 5 squared. Complete the square. I kind of did this really casually in my head, but be careful. That's going to give me c squared minus c plus a quarter. Times it all by 4. I'm going to get 4c squared minus 4c plus 1. And I need to get to minus 5, so it's going to be minus 6 all squared. Okay, I'm now going to change it back just to kind of make it more of a maximum rather than a minimum, because this has a minimum, and I'm just going to work it back to make sure it's got a maximum. Squared. Okay, now I can see quite obviously max value occurs when c equals a half, and c can equal a half because cos x equals a half when x is pi over 3. Yeah, I was just converting degrees there into radians. Apologies for that. When cos x is 60 degrees, in other words, when x is 60 degrees, in other words, when x is pi over 3. So that's certainly possible. And when that's the case, all of that goes to 0, and the answer is 36. 6 squared, 36. And so the answer is B. Okay, that's the first 5 questions. Hope you found it useful. Next 5 will be posted very soon. Keep up the great work. Good luck in the mat as well. Bye-bye.